Okay, everybody see okay?
Yeah, so you see the presentation. So next up we have Aaron Sanchez, who's going to be speaking to us on how humans affected the spread of zebra mussels. Aaron, whenever you're ready.
Hello, my name is Aaron Sanchez. I'm going to be talking about how zebra mussels affected the spread, how humans affected the spread of zebra mussels. Dracaena polymorphia. What is a zebra mussel? A zebra mussel is a small bivalve mollusk that range in size from 1/8 inch to 2 inches long. They are mostly white or cream colored with jagged brown or black stripes, like a zebra. A more unique trait of a zebra mussel are their strong byssal threads. These threads form strong bonds to several types of substrate, including metal, glass, wood, aquatic plants, other crustaceans, and even to each other. Zebra mussels can filter around 1 quart of water daily, making them very efficient filter feeders for their small size. They thrive in fresh, moderate temperature water that is 2 to 12 meters deep, but can live much deeper at about 110 meters deep. They must have solid surfaces in their environment to attach to in order to survive to maturity. A result of this is that zebra mussels have become creative in what they attach to. When waters reach around 54 degrees Fahrenheit, the mussels reproduce, releasing 30,000 to 1 million eggs a year. When fertilized eggs develop, they develop into free-swimming larvae called veligers. These veligers ride water currents, eating tiny phytoplankton. At about 3 to 5 weeks, the veliger shells are heavy enough to weigh down, and they must find a place to attach to. Within a year, the newly attached mussels grow to their mature size, and they're able to begin reproducing. One of the first questions when talking about an invasive species is, how did they come to be here? It is suspected that zebra mussels came to the US in ballast water from a transatlantic cargo ship. They're indigenous to Eastern Europe and Western Asia and had been present in freshwater systems in Europe, Scandinavia, and Russia for hundreds of years. They made their first appearance in the US during the late 1980s in the Lakes Basin. This is a time-lapse map that I created as a final project for GOG 586. And I'll get started. Zebra mussels were released on the northwest side of Lake Erie in 1987. Over the next 4 years, they populated the Great Lakes region and expanded up the St. Lawrence River into Ontario, where they would later spread as far north as Quebec. By 1992, zebra mussels had been found in the Hudson, the Illinois, the Ohio, and the Tennessee rivers. They made it down the entire journey of the Mississippi River and were recorded in the Mississippi River Delta in 1994. Over the next decade, Kansas, Oklahoma, and Nebraska would see their rivers and lakes populated by zebra mussels as well. Over the next few years, zebra mussels made the jump to Colorado, Utah, Texas, and even California. The most recent population expansions have been in Minnesota and North and South Dakota. Currently, there are zebra mussel populations in 33 states. As you can see, zebra mussels spread quickly and can reproduce in large numbers. But what makes a zebra mussel invasive? An invasive species is a non-native to its ecosystem and whose introduction to the native population causes environmental or economic harm or harm to human health. When zebra mussels invade an ecosystem, they filter an immense amount of water. This sounds like a good thing, but by over-filter feeding, zebra mussels create an environment with increased water clarity and scarce plankton, which can lead to a change in the ecosystem's food web. With increased water clarity, fish habitats change, causing some fish to seek deeper water and others to decrease in numbers. More light in the water column also increases aquatic plant growth. Overgrowth of aquatic plants can become challenging for boaters, swimmers, and also change fish habitats. The mussels' abilities to filter so much water and their numbers, they outcompete native species. Zebra mussels do filter toxins from the water, but those toxins get stored inside of them. When they're eaten by other wildlife, they can cause harm with their toxicity. One of the unique parts of a zebra mussel are their strong viscal threads. These threads form strong attachments to most solid surfaces. Since zebra mussel veligers or larvae are free swimming and microscopic, they have the ability to get themselves into problematic places, attach, and grow. Damage and fouling of infrastructure due to zebra mussels is $1 billion a year problem in the US. Mussels can attach and grow in water intake pipes and irrigation systems, blocking water flow and decomposing water lines. Hydroelectric plants and dams have costs associated with removing mussels from pipes and structures and maintenance to keep them from reattaching. Attachment to ships and boats can cause problems with drag and erosion of the hulls and engine problems. Buoys and other water structures require more maintenance to remove mussels in order to function properly. Zebra mussels can also attach to other crustaceans and plants in their environment. Lastly, zebra mussels leave behind invasive waste. They filter feed most organisms they come across, but don't consume filamentous algae like blue-green algae. This promotes blue-green algae growth and can cause toxic blue-green algae blooms. The decomposition of zebra mussels consumes dissolved oxygen in the water. When there is an event of a large die-off, the amount of oxygen the mussels consume has an effect on the organisms in their environment. Another result of a large die-off event are windrows of zebra mussel shells that wash up on shorelines of lakes. Because the shells are small and sharp, it makes the lakefronts unusable during these events. The current control measures for zebra mussels are thorough ship and boat washing, which can keep zebra mussels from jumping into new waterways, sodium hypochlorite systems and anti-fouling coatings, which can stop attachment, and physical removal is used to clean areas already infested. Eco-DNA testing can also be used to test for veligers by testing water for zebra mussel DNA. In my previous project, I created a map that showed the spread of zebra mussels over time. The data points used were zebra mussel counts provided by the USGS, those counts locations, and the year they were reported. For my capstone project, I would like to add more elements to further analyze why zebra mussels spread the way they did. Humans' greatest effect on their spread has been through water vessel traffic. For this project, my goals are to create a baseline map by showing how zebra mussels have spread through natural factors, like water flow direction, surface geology, and temperature constraints. I will then show how zebra mussels have spread due to human influence by using water vessel traffic information. I will then analyze the difference between these two spread patterns. My methodology to complete this project will be to collect the data needed from reputable sources. The USGS has most of the data that I'm using. I will be using ArcGIS Pro to create the spread maps based on environmental factors and human factors. The environmental factors will be flow direction, water depth, maximum minimum temperature, and surface geology. The human factors will be commercial shipping channels and recreational boating zones. The results I expect to see with a natural spread are I expect to see the spread to move downstream. Even though zebra mussel veligers can swim, they can't swim against currents. Their spread should also not move into bodies of water that are coastal or have high salinity. These mussels should not spread to environments where the temperature is out of range or where the surface geology doesn't provide enough solid surfaces for their attachment. The human affected spread should show unnatural spread distance, meaning they caught a ride on a ship. It should also show spread to unpreferred bodies of water for a short time, like the Mississippi Delta, where there were only counts for 1 year. The human affected spread should also show zebra mussels that travel upstream or those that cross areas of land. My project timeline is pretty straightforward. The past few months have been the planning phase where I chose my topic, researched the history of it, and studied previous projects done on it. Right now is the peer review proposal. In the following months, I will continue to research information to get the data that I need to fulfill the goals of the project. My final presentation will be sometime in the spring. I have not found my venue yet, so I'll be looking for that in the next few months as well. Invasive species enter an ecosystem and cause environmental and economic harm. Zebra mussels change the water column, outcompete native species, and create damaging waste products. They cause billions of dollars of damage to infrastructure and maintenance programs. As much as zebra mussels affect us, humans have had a large impact on their rate and range of spread. With this project, I hope to visualize just how much humans have affected the spread of zebra mussels. And that's it.
All right, thanks, Aaron, for your presentation. Good job.
Thank you.
So if anyone has any questions, just go ahead and unmute and you can ask, or feel free to enter the question in the chat window. That's fine too. One question that kind of came to mind is, are you focusing in on looking at areas that potentially could be populated with these zebra mussels, or are you looking at existing areas and how the infestation is changing? Or I guess I wasn't clear on geographic scope of your project. Perhaps you could explain that a little bit.
Sure. My first step was going to be to use the history of it, so go from the 80s up and show how they spread. I did want to do analysis where I took it the step farther and showed where they have potential to go next. That was one of the thoughts that I had also.
And is that just in states that the mussels aren't presently found, or are you looking at other water bodies in states where the mussels are presently found, I guess?
I wanted to see where they would go next. Like if, like the states that don't currently have populations of them, or states that only have very little population. Like Utah has very little because a lot of Utah has, well, Salt Lake is not going to have zebra mussels in it. So that was the thought, that I wanted to see if they would spread to other states that don't currently have them or have low populations. Okay,
all right, thanks. Looks like there's a question in the chat window for you.
Yeah, I was trying to bring it. Oh, okay. Kara says, yes. How are you planning to incorporate temporary infestation data into your analysis? Temporary infestation is hard because it's usually, for me, that would say that it was a man-made, a human-influenced spread. If it was only there for a few months or less than a year, then the population wouldn't have spread there naturally. So that's how I would probably handle temporary infestation, is that would go into the category of a human spread.
I had a quick question, Aaron. Good job. Mine was sort of a follow-up of Fritz's. He had the same, well, similar question that I was thinking of. And so if you do take it forward and sort of like predicting where they might go or how they might spread, I'm assuming there would be, you know, from all of the research that you've done, you would potentially have some sort of mitigation strategies or something like that, so that some of those places that don't have them now could avoid the problem. Is that what you're kind of thinking?
Yes, most states have mitigation procedures in place, but yeah, there isn't a whole lot that they do at the moment. They're really hard to control. So at the moment, they kind of just scrape them off until they can figure out better ways of controlling them. But yeah, that would be a good point to do, is that how to give pointers on how to stop continuing the spread once it's already there.
Thanks.
So I might have missed this, but does the resulting analysis, is that only covering the population distribution and changes across space, or is it also looking into the effects of the muscle in a particular location? Like, do similar populations in different locations cause, similar amounts of damage, or is it different?
Similar populations of mussels or similar populations to everything other than mussels?
I mean, I guess mussel, if there's a similar amount of mussels in one location and a similar amount in another, do the effects of those, are those similar, or are they different?
From what I found, they're pretty similar, but it would also depend on what animals were around. The fish that are up north are different than the fish that are in Texas. So that would be a different impact on how much of the population around them that they affect. But that's a good point.
This is Kara. I will just not type instead. I do have a question. Out of curiosity, how are the mussels controlled in their natural environment that they don't have the same problem over there that they do here?
I don't know that one. I hadn't looked that one up. I do know that I ran into problems finding older information because a lot of it was in German. There's a lot of studies about it in Germany. So I know that it's a problem everywhere, but I don't know how they handle their populations.
All right, any other questions for Aaron? All right, thank you again, Aaron, for a great presentation. Make sure that the presenters refer to the peer evaluation form. Beth put a link to that form earlier in the chat window. If you can fill that out, that would be great. Otherwise, we have another round of 5968 presentations tomorrow at 11 a.m. Eastern Standard Time. So if you tune in, I'm sure we'll have some interesting talks there. So I wish everyone a good rest of their evening or day, wherever you happen to be.